Hey, good morning. Happy Friday. Let me fix my camera again. 1 second. Yeah, there we are. Good morning. Happy Friday. Today we're gonna talk about multimodal document processing. So it's a really cool feature, and I hope you will enjoy it as much as I did when I actually implemented this for a few customers. So looking forward to that. I see we have people in the chat asking for the live stream schedule. I have a website. It's called ml-engineer.dev. And there you get the full schedule, and you also have all the previous recordings and upcoming planned sessions. Let's have a look, and then we can get started. So let me head over first to the live stream schedule. This is how the website looks like. You have the upcoming live streams on the left and the past live streams on the right, with all the articles and the YouTube videos. So if you missed something, get there. All right, let me put this up here on my screen. All right. Today we're going to take advantage of multimodal capabilities around the Gemini model. And the cool thing today, we don't need any training, we don't need any labeling, and we basically just write a prompt and get the results based on what we want to extract from the documents. And I think the best thing of all of this literally takes you 15 minutes to implement, and maybe another 15 minutes to put into production, and it's ready to go. So I hope you are curious to see how this works, and let us get started, dive into it. But before we actually go to the code, I want to showcase you the use case. So let me open up another slide here. This is the use case we're going to talk about today. So it's about the invoice document, but it could be any kind of document. Later on, you will see how we can adapt this to different type of documents within seconds. So imagine being able to process any kind of documents and adapt it to any type of document within minutes. In the past, with this more traditional machine learning approaches, extracting structured data was very slow and tedious and time consuming. We had to label data for weeks, maybe, depending how many people actually label the data. The models were actually very fragile. So if there is a new type of document, they most likely fail to extract the information. And now with multimodal capabilities, which we have now since the last 2 years, since the rise of generative AI, we no longer need to manually label any type of data. We can now simply write a prompt and define our desired output, and the model understands on how to extract this information from, for example, from an invoice. And it adapts to new documents within seconds, as I said. So enough talking, let's head over to the code. Let me first show you the overall architecture, and you better understand what we actually implement. So this is what we have. We have our Gemini model in the center. On the left side, we have a document. Document could be a PDF, but it could be also an image, like a scanned document, or someone sends you a document via PDF. We combine it together with a prompt and send it to the Gemini model. And with the Gemini model, there is a feature which is called control generation. I covered that in, I think, one of the first live streams where we did this orchestration stuff around AI. There also we used control generation to generate the recipe. We're going to take advantage again of this feature and use it to extract information out of our documents. And we can do that by defining a response schema. And then we're getting actually from this document, which we want to extract, we get the data as a JSON. So we can use it in subsequent processes to actually do something with it. All right, enough talking. Let's go to the fun part. We head over to the code. Let me go to the top. As we can see, it starts, as always, let me put this to the side here. It all starts with the stuff we need, our boilerplate code. So we use the generative AI model. We initialize Vertex AI. And here we have our prompt. You see, it's a very simple prompt. I say you are a document entity extraction specialist. Given a document, your task is to extract text values of entities and generate null for missing entities. Very simple prompt. Obviously, if you have maybe more sophisticated documents, you can do prompt engineering, describe what your document is about, describe what you want to maybe extract in a more specific way. But for our use case, because we are using control generation, we are telling the model with our control generation what we want to extract. We'll see that in a second. And here I'm loading a document from my local file system. It's a PDF. And we are having this helper function from the Gemini SDK, from the Vertex AI SDK, which helps you to implement parts. You see, a part is something which you want to send to your model. And because we have this multimodal capabilities, we have actually multiple parts. We are sending a document to our model, but also text, our prompt. And this is split up into parts. And you see, we can call generate model here at the bottom. And here we are sending a text part and an image part. That's how the definition of part is. This could be also a PNG, so it could be also an image, but you could also load the data from a cloud storage, for example. So there is a helper function which directly loads the data from a cloud storage if your data is stored there. And here's the interesting part. That's what I mentioned, what we already covered before in one of the previous live streams. We can define the output of our Gemini model, and it will strictly follow exactly this structure. As you see, we don't need any further prompt engineering here. So we instruct the model basically just to extract the entities. We don't even tell the model what kind of entities, because this is something that we're going to define as this structure. All right, let's have a look into the document. So you see we have items, and each item has a description, a quantity, and a total. And if we open up this PDF here, let me open this for you. I think it's this one. Let's open the image. You see we have this table. We want to exactly extract this table with the items, the quantity, the price, and the total. And the really cool thing is here, you see this is called quantity in a short term, but we actually, let me go back to the code again, we actually call this quantity. So the model can understand it doesn't have to be a perfect match. The model is capable enough to adapt to changes. Right? If you have a document, if you're getting invoices from different companies, they probably call it all slightly differently, but the model will still understand what it's supposed to extract, so it doesn't have to be a perfect match. And I think that's one of the really nice capabilities, which makes this extremely flexible also to adapt to new document types. So, and from there we use the Flash model. Just yesterday I published a post on LinkedIn. Flash now also supports this response schema. Until a couple of days ago, Flash only supported the MIME type, and you had to give an example of your JSON as part of the prompt. But since a couple of days, probably you can also use the response schema with Flash. So it's not only an exclusive Pro feature anymore, it's now also available with Flash. And then you see we have the generate document where we are passing our parts. We have a document part, which is our PDF or an image, and we have our prompt and our generation config. And from there, we take the response, and I also store it as a JSON file just for us to better see how the response actually looks like. Let us run this. For some reasons, my keyboard is not really working here. Check again. Let me put a cable on it. Yeah, this looks good. So let's clear this from the last one. We run Python, this multimodal.py. It's again, as always, everything on GitHub. You can give it a try there yourself with your own documents. It takes obviously a few seconds because we are sending a document and we processing a document. And now you see we get exactly the response back from what we had in our document. We're having our items. And additionally, we also get the invoice number. So if you go back to the document, you see we also have an invoice number here on the top, and it understands where to extract the invoice number. And it's not even listed as invoice number, and it still understands it. If now you get a new requirement from your invoicing team that they also need the date issued, all right, you go back to your code. You open up the code again. Go to your response schema and you add date issue to it. And for now, I do this as a string. We could also use a date type. I think a string is also fine. This we don't need for now. We can clear this, run this again. And now we are also getting the date issued. Let me go back to the document. So it's 20th of August. Let's see if this is actually correct. Yeah, so it's correct. You see, it is really flexible because we are using the multimodal capabilities. It adapts to document changes within seconds. It's very easy to extend. And keep in mind, we haven't trained any model, nor have we labeled any documents. This is literally done in just a few minutes. If you have really complex documents, you still could provide a few examples called few-shot to the Gemini as a prompt. So you could provide an image and an extraction, an image and an extraction. This could further improve the model if you have very complex documents, and it still doesn't require any training. Just everything in the prompt. Together with this control generation, we can then actually get the information we need or we want in the format we need, like the JSON here in this case. All right, you see it took us 10 minutes. Obviously, I haven't implemented this now live in the live stream, but if you implement it yourself, just a few lines of code. Let's see how many we actually have here. Let's go to the code. So it's approximately 50 lines of code with a lot of white space in between and storing it as a JSON. So it's very easy to implement. We also have this result JSON where we can now see the output, and you could do something with it in a downstream task. So it's very easy to implement. I also checked how the pricing is for this, and this was my catch line, which I showed in the beginning. Where do we have it? This one. So how to process 10,000 documents built within 15 minutes. Let me open up the pricing for you. Where do we have it? Costs. But those are the costs. This document I processed here, it processes approximately 500 tokens for input and 100 tokens for output, and we need to process one image. In this case, it's a PDF, but it doesn't matter if it's a PDF or an image. One page in a PDF equals to one image. So if you have a PDF which is 2 pages long, it equals to 2 images. So this is our input we have. And from there, we can calculate the pricing costs or the cost for processing these documents. And you see it's extremely cheap. This is the cost to process this type of invoice. And if we split this down to $1, you can process a little bit more than 10,000 documents with just $1 if you're using Flash. If you're using Pro is more expensive. You can approximately process, it's around 200 documents. So it's a big difference, 200 with Pro versus 10K with Flash. So take this into consideration. I usually say start with the smallest model possible see if this fulfills your requirements, and if that's the case, take the cheaper model. Only if you have a very complex use case where Flash doesn't work well, then you maybe can consider using Pro, but first try more optimizations, do prompt engineering, do better few-shot examples. In this case, Flash is capable enough to actually do that. There's another product, and this is something where I got a question from a customer a couple of weeks ago. They use Document AI. And Document AI is a specialized product for working with documents. There's also entity extraction, and you can train your own document or entity extraction models there. And you need to label data. Things are speed up. There's now also generative AI integrated into Document AI, so you just need to label a few tens or not more than 100 documents to actually get started there. But it's still more expensive. If you're using Document AI, you can, for $30, you can process 1,000 documents. And if you're taking $30 for our approach, we can process over 300,000 documents. So our custom solution with Gemini Flash versus Document AI, it's a lot cheaper. It's 300,000 documents with Flash versus 1,000 pages with Document AI. So it's a big difference. And if you're using Document AI, you could consider, if you have an easy use case, to maybe switch to this approach. And it would save a lot of money, and you can have a better business use case, right? Benefits and conclusion for this approach. I think, as I said, with traditional machine learning, we had to label a few hundreds or thousands of those documents. We had to train our own model. We probably need to do some OCR before we actually do the entity extraction. Those times are over. With multimodal models, we only need the prompt, a multimodal model like Gemini, few lines of code, and that's it. Let me also show an example. I put this behind a Cloud Run endpoint. So if you want to put this into production on your side, there's on GitHub later on, I think I already pushed it. There's this Cloud Run service where this is basically the same, just behind an API endpoint. And I also have a small UI up and running where you can, it's a Streamlit application where you can actually give this a try yourself and run it. So if we go here over, this is how the application looks like. Let me reload it. It's running on Cloud Run, so the UI and also the API, which is doing the processing of the documents. So it has a cold start because I downscaled it to 0, but we can upload a document here. Let's take the PDF. Have a small preview on the right side, and then we can run extract information. As I said, there's a cold start time, so it takes a few more seconds for the first time. And here we have it. And now you see we're getting exactly the same thing. And what makes this very flexible, I mentioned it's a control generation where we are passing the structure which we want to retrieve. The model understands what it needs to extract. We could theoretically pass this response schema as a parameter to the API. And you could do the extraction of additional information in real time by just passing it to the API point. So it's very flexible. I'm currently also building an UI where Gemini first analyzes the document, and then it suggests how the response schema should look like, and you basically have a UI where you can click and select what you want to extract. But we'll probably cover that in another session. All right, if there are any questions, you can post them in the chat. If not, as I said, it will be all on GitHub. Give it a try with your documents. If you have any kind of document processing use case, you can use it, right? It's not only invoices. Any kind of document where you want to extract something could be useful for this approach. For the schedule, next week we either talk about context caching or Cloud Run GPUs. I'm not quite sure yet. I see what I'm up to, one of those two. And the week after, there will be no live stream, but then we continue. All right, by the way, if you have topic suggestions, write me on LinkedIn or ping me wherever you are connected with me. I'm happy to get your topics also up on the agenda. And I hope you enjoyed this session. As always, I wish you a wonderful weekend soon and see you next week.